It's 1 through 6. Okay, so take your orange piece of paper. We're going to make our foldable. Take this orange piece of paper, fold it hamburger style. Or taco style. Then fold it hamburger and or taco style again. So, you should have something that looks like this. Now listen carefully. You're going to take your scissors and you're only going to cut one part. You're going to cut this line right here and just that line. Take this, cut it just like this. Only one sheet though. So you should have something that looks like this. Has 2 flaps. Just 2. You did a fantastic job. His cut isn't even straight. I don't know about that. Okay. So, we are going to write 2 things. First thing you're going to write is conjecture. This is going on one of the flaps. So this goes on one of the flaps, right? Conjecture, that's a J. I know, this is someone else's writing because my handwriting is really bad. I think so. It's always Tuesday, 2 days, yeah. Mm-hmm. Yeah, you can take that. We're grading that on Tuesday, yeah. All right. On the other flap, you're going to write counterexample. You're writing conjecture and count. Yeah, perfect. It's good. Except for you did the hot dog hamburger style instead of the hamburger style. Counterexample. Oh, yeah. All right. The definition of a conjecture is an educated guess based on known information. Yes? But you already interrupted. Okay. An educated guess based off of information. Okay, in order to make... Oh, one more thing. A conjecture, you guys have kind of heard of conjectures before, but you've heard of them as something different. Does anyone know what I'm talking about? In science class. A hypothesis. Conjectures are very, very similar to hypothesis. In fact, most people consider them interchangeable. Okay? It's an educated guess based off of known information. In order to get a conjecture, you have to do two things. First thing, you have to make an observation. You have to notice a pattern. Make an observation or notice a pattern. Second thing you have to do is you have to make a conclusion about what you noticed. There's one really big thing about this that you all have to understand. What do you guys think I think is the most important word in this in all of this? Nope, not conclusion. Notice? Pattern. Pattern, no. Observation. Nope. Guess. Most important. Answer is guess. I said guess. I think the word guess is the most important information in this. Why? Because one, it's an observation. You guess based off of your observations. Two, it's just a guess. It's not always going to be right. Most of the time, it won't be right. Guesses aren't always right? But you use the information given to you to make your best guess, to make an educated guess based off of the information you know. So, for example, let's look at this one. We have this number sequence, 1, 3, 9, 27. Try to find a pattern in there and guess what the next number will be. I'll give you guys about a minute to do that. Mm-hmm.
Oh, I already know what it is.
What is it?
Can I say it?
How about you write it down? What the next number is going to be. Mm-hmm. Yeah, write down the number. What do you think it's going to be? All right, let's think about this. We have a 1, a 3, a 9, and a 27. So from 1 to 3, how did we get from 1 to 3? Times 3. What's another way to do it? Plus 3, 1 plus 2. Okay, let's go from 3 to 9. Times 3. Can we add 2 to it? Plus 2 would be 5. So we know it's not plus 2. How about from 3 to 27? What did we do? Times what? Times 3. So we think our next number, based off of our pattern of multiplying by 3, is going to be 27 times 3, which is 81. So we think our next number will be 81. What did we do there? We made an observation. Our observation was that we were multiplying each number by 3. And our conclusion was the next number will be 81. Do you see both steps we made there? It's 2 distinct steps. It might not feel it all the time, but every time you do this, you should be making 2 steps in your head. Make it a good start. Mm-hmm. All right. There's the answer, 81. Wouldn't it be awkward if I missed one, especially in 7th period? All right. Draw the next shape. Draw the next shape. Man, you're not going to like geometry then. Okay, let's look at our pattern first. Our first one was a single block, right? Second one was 4 blocks. Our next one was 9 blocks. Oh, this is not going to end well. Recovered. Oh, ignore the 16 for now.
Oh.
Okay. So, let's look at our patterns. We're going from 1 block to 4 blocks. How do we go from 1 to 4 blocks? Times 4 or add 3. We're going to go from 4 to 9. Okay, 4 plus 3 is? 7 can't work. All right, what's times 4? What's 4 times 4?
16.
Is this 16? Then our pattern's not working for either of those. So it's something different. Plus 5. Okay, 1 plus 5 is?
Squared.
It is squared. Good job. The first person to get that. Okay, so let's think of it a different way, though. This is a 1 by 1 square, right? It's 1 square by 1 square. This is a 2 by 2 square. This is a 3 by 3 square. So what do you think the next one's going to be?
4 by 4.
A 4 by 4 square. It's going to look something like this. Right? It's going to look something like this. That's going to be a 4 by 4 square. And it should have 16 blocks. Now, here's the thing. What if we wanted to find, I don't know, the 10th shape in the pattern? Does anyone know what it would be?
10 by 10.
It would be a 10 by 10. How many squares would that be? 100. Watch this. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 4 times 4 is 16. So if we wanted to find, I don't know, how about the 5,000th spot? It'd be 5,000 times 5,000. It's the same as the position squared. All right. Oh, one more. You guys already saw the answers, though. All right. This pattern, try doing this one all on your own. Don't yell out the answer. There's 3 people missing. Joanna, and then Suni's missing. Who's the last person? Oh, Jose. Jose is missing. Okay. The pattern for this one is you multiply each number by 10. So the next number would be, multiplied by 10, would be 10,000. Okay. Yeah, it's the same as multiplying by 10. Yeah. All right. Counter example. A counter example. A counter example, the definition of counter example is an example used to show a statement is not always true. It's based off of the word define. You drop the E and add ION. No, it is defined. Oh, definite, sorry. Man, you beat me. English is not my strongest. Oh, this is spelled right. I was saying definite. And if it was based off of define, it would be ITION. So you drop the E and add an I. Mm-hmm. Define. Okay, so this, you know what this reminds me of? Counter examples remind, you know how you've got one friend who likes proving you wrong? So you'll say something like, you'll say something like, you know, all birds fly, and then your friend would say, well, actually, penguins don't fly, right?
Penguins are birds?
Yeah. Well, so what did you learn in geometry class today? Oh, I learned that penguins are birds. Okay. So, the one counter, would this be a valid counter example? If I say all birds can fly, and then you say, no way, dude, birds fly, did you prove me wrong? No. A counter example can't just be you saying your conjecture again. Here's an even better example. If I say, all dogs are black. Would a counter example be, no way, dude, my dog is black? Does that prove me wrong?
No.
You cannot just repeat the same example again as a counter example. That sounds silly, but I guarantee you people will do that on the test. So, for my first example, if a creature has 4 legs, then it must be a dog. I want you to write this down and figure out a counterexample on your own. Don't yell it out. Raise your hand when you think you know one. Down there. So a really bad counterexample would be, if a creature has 4 legs, then it's a dog. If you were to say, no way, my dog has 4 legs. Oh man, missed opportunities. A deaf dog? Is this a joke?
Yeah.
What do you call it?
Doesn't matter what you call it, it's still
Where do you find a dog with no legs?
dead.
Where you left it?
They can walk.
How do you start a counter? With a C. With a C. What? With a. How do you start a sentence? With an A. Me too. Okay. So, Handy, if you want to give me a counter example to, if a creature has 4 legs, then it must be a dog. What's your example? What's your counter example? Cats have 4 legs. Does anyone else have another counter example? A cow has a horse. Anyone else? We already said cat. You did. A lion. Giraffes have been awfully popular. Like at least an elephant. A whale does not have 4 legs. Nor. Okay. Okay, a camel would work. All right, our next example would be if a student plays an instrument, then they are in the band. Think of a counter example to that. Don't say it out loud. Don't say your answer out loud. Wait to be called on. In band. Not even paying attention. Okay. So, the example would be what? Does anyone know the answer? I know orchestra would be a good example. Finally, 2 rays that have the same endpoint make a blank. Make an acute angle. Can someone think of a counter example to that? Two rays that have the same endpoint make a acute angle. Can someone think of a counter example to that? 2 rays that share a same endpoint that, in this example, do not make an acute angle. Okay, so 2 points that share, 2 rays that share an endpoint. So we have a shared endpoint and 2 rays, a ray here and a ray here. Think of clock hands. That's like how I think of it. What angles could 2 rays make? A right angle, is that an acute angle? So that's a valid counter example. So, a right angle, an obtuse angle, and there's one more, a straight line. Okay. All right, your homework is the front page. Work on it. I'll be right back.
Where are you going?
Go from P.